You know what's more radical than simplifying radicals? Well, what we're doing today is more radical than simplifying radicals. We're going to do operations with radical expressions, so like adding, subtracting, multiplying, and dividing. And that's what our two goals, our learning targets for today are based on. So we're going to first simplify sums and differences of radical expressions. It's going to be very much like combining like terms. Then we're going to also multiply and divide. So we're going to simplify products and quotients of radical expressions, and that's where it's going to be. There's going to be a lot of similarities to things you've done before, but there's also going to be some new things. So a couple terms as we get started. Like radicals are just like terms. They're radical expressions with the same radicands, or the portion under the square root is the same. So here's an example. 2 square roots of 3 and 5 square roots of 3. We're treating them like the square root is like a variable. Okay? Unlike radicals are radical expressions that do not have the same radicands. So example here, we could say 2 square roots of 3 and 3 square roots of 2. They don't have the same underneath the radical. All right, and conjugates are the sum and the difference of the same two terms. So like a minus b and a plus b. Those are called conjugates. Same things, only the one is adding and one is subtracting. We're going to use conjugates today. All right, so combining like radicals. Radical expressions in which the radicands are alike can be added or subtracted in the same way that monomials are added or subtracted. Okay, it's like combining like terms. So consider the radicand to be like a denominator. You must have a common denominator when adding or subtracting fractions, just like you must have common radicand to add in order to simplify. I would also say treat them like they're a variable. If you have 2x's and 4x's, that makes 8x's. Or sorry, 6x's. You have 6x. If you have 2 square roots of 2 and 3 square roots of 2, that makes 5 square roots of 2, because they're like terms. So, a couple examples here. We have 3 different terms that are alike. 6 square roots of 5 plus 2 square roots of 5, and we're going to change this to plus a negative 5 square roots of 5. So 6, so we're essentially doing 6 plus 2 plus negative 5, and then we have the square root of 5. 6 plus 2 is 8, plus negative 5 would be 3, so we end up with 3 square roots of 5 is our simplified result. Okay? Another example here, we've got some like radicals. So we have square root of 7 square roots of 2, which changes to plus and negative, and we have negative 6 square roots of 2. Then I'll put circles around the 8 square roots of 11, changes to plus and negative 4 square roots of 11. So for the square roots of 11, we have 8 plus negative 4, and whoops, we then have the square roots of 2, we have 7 plus negative 6. Alright, and that reduces to 4 square roots of 11 plus 1 square root of 2, or just the square root of 2. And that is fully simplified. Your turn. Why don't you try pausing it? I'll show it in a second. And essentially combine like radicals for each of these two expressions. Go ahead. Alright. So combining the like radicals, we got 7 plus negative 8 square roots of 2, which is negative 1 square root of 2 for the left one. And on the right one, we got 5 and 2, each square root of 5. So that makes 7 square roots of 5. Alright. Sometimes, if you look at this example here, you may have radicals that do not have the same radicand. So we may need to do some simplifying like we did in the last lesson first to determine if they can be added or subtracted. So the first one cannot be simplified any farther, but this one certainly can. Let's do the square root of 4. That's a perfect square, and times the square root of 3. 4 times 3 gets you 12, so that's why that works. Okay? And so that would be even that like that, and this is going to be 2, so we have 2 square roots of 3. So what we now have is 5 times the square root of 3 minus, this is going to be 2 square roots of 3. Now we can simplify or add like terms. We can change this to a plus and negative, and that would be 5 plus negative 2. And we have the common square root of 3, so that would be 3 square roots of 3 as our final answer. So we had to simplify one of them first. All right? So we have two examples here. I'm going to do the one on the left, and then I'm going to have you try the one on the right by yourself. So this one cannot be simplified, so we know we're going to have 4 square roots of 7 plus something. But this one can be simplified. We have the square root of 4 as a perfect square and the square root of 7. Okay? So that's going to stay there. We also have the 2 here. And we also have, this would all be another 2. So we have 2 times 2, which is 4, and then the square root of 7. So now we have 4 square roots of 7 plus 4 square roots of 7, and that equals a total of 8 square roots of 7. Okay? Why don't you pause it and try the second one on your own? Hint, hint. You may need to simplify both of them. All right, so I simplified on both. The one on the left, when you factor it, you end up getting 20 times the square root of 2. And the one on the right, you end up getting 12 square roots of 2, but I changed that plus or that minus to plus and negative, and you end up getting 20 square roots of 2 plus negative 12 square roots of 2, which is a total of 8 square roots of 2. Okay, so that is adding and subtracting radicals, and sometimes you might have to simplify first. Here's where it gets a little bit tricky, is when you multiply or divide radicals. Okay, so when multiplying radicals, or when simplifying a product like this, you can use the distributive property. Okay, we're going to use the distributive property, and then if we need to simplify, we can simplify after that. If both factors in the product have 2 terms, so then we're going to use the FOIL method, just like we have before with multiplying a binomial. So this first example, we're going to distribute. The square root of 10 goes to both the things on the inside. All right, so then we have the square root of 10. That gets us the square root of 60 plus the 3 times the square root of 10. The square root of 60 we can simplify, which is going to be 2 square roots of 15 plus the 3 square roots of 10. Can't simplify either of those any further, so that's our final result. Fully simplified. All right, here's an example of where you might have to use FOIL. Using the first, the outsides, the insides, and the lasts. All right, when you do that, you get 4 terms. So we've got square root of 6 times square root of 6 is the square root of 36. That's the first. The outsides, we get the square root of 18. The insides, we get minus the square root, 2 square roots of 18. And the last, we had minus 2 square roots of 9. Some of these things are going to simplify. And we have some like terms too. So we have 6 right here. This is going to be minus 1 square roots of 18. And this becomes minus 2 times 3, which is minus 6. All right. Breaking apart the 18, we get square root of 9 and square root of 2, so that's going to be 3 square roots of 2. But these like terms here as well are going to cancel out. So those are gone, and we're just simply left with negative 3 square roots of 2. So all that simplified down to this. All right, so we're kind of bringing a lot of things together, the FOIL method and also all of our simplifying of products. So I have an example for you to try. Actually, I have 2 examples for you to try. Scratch that. I have 3 examples for you to try. Okay, I'm going to give you a hint on the second one. Make sure you write it out. Don't assume that you can square each of the things. That would be the square root of 11 minus 2 times the square root of 11 minus 2. Okay, so I'll pause it, try these. I'm going to go through those also in a second. All right, lots of simplifying, but the first one, it's using the distributive property, and I can simplify the one part, square root of 12 here, and you end up getting 2 square roots of 3 plus 5 square roots of 2. Second one, a little bit more work. You got to do the FOIL method, and after you do the FOIL method, which I have labeled here, a couple things simplify, and then you can combine like terms. You end up getting 15 minus 4 square roots of 11, or negative 4 square roots of 11 plus 15. And the last one was the most work. Um, the FOIL method gave us a lot of stuff to simplify, and I showed kind of how I simplified in the red there. But I got 12 square roots of 2 plus 18 minus 24 minus 18 square roots of 2, and then I combined like terms to get negative 6 square roots of 2 minus 6, or negative 6 minus 6 square roots of 2. Okay? So the last part I want to touch on was the dividing part. It's going to be very similar to the multiplying part, but sometimes we might have to add one extra step. So, when rationalizing a denominator, which we talked about last time, we want to multiply by the same thing as the denominator on the top and the bottom to get rid of the square roots. But sometimes the denominator will have a sum or difference of two terms. So think of these like you would a difference of squares. Because when you multiply conjugates, which we talked about right here, opposites, a minus b and a plus b, the inside and the outsides actually cancel each other out. So it ends up being whatever a squared is minus b squared, which will simplify nicely when you have radicals. So how we're going to use that are like this. 7 plus square root of 7 plus the square root of 3, and the square root of 7 minus the square root of 3 are conjugates. So we're going to want to use conjugates when we multiply the other side. So when you FOIL those, if you were to FOIL those, you get square root of 49 minus square root of 21 plus the square root of 21 minus the square root of 9, which ends up just, these two cancel each other out, which is an awesome thing. So that's why we are going to multiply by the conjugates when we want to rationalize a denominator. So here is an example. We have 10 over the square root of 7 minus the square root of 2. So what we're going to do is we're going to multiply the top and the bottom by this. Square root of 7 plus the square root of 2 over the square root of 7 plus the square root of 2. That is the conjugate. Okay? Now we have to go back to what we just learned with multiplying. We have 10 times the square root of 7 plus the square root of 2, because we're like distributing here. And on the bottom, we're doing the FOIL method. But as we talked about conjugates, the middle terms cancel out. So we're just doing the square root of 7 times the square root of 7, which is 7. And the square root of 2 times the square root of 2, which is going to be the square root of 4, which is 2. And we're keeping the minus sign. So we just have 5 on the bottom, and then we have to simplify the top. All right, but you could, before you distribute, we can simplify here. 10 divided by 5 is 2. So we have 2 times the square root of 7 or plus the square root of 2, and then distribute. And that is our final answer. So we do have to do some multiplying by the conjugates. And I'm going to give you one example to try this. Okay? And the conjugate now, so if we have negative 3 over the square root of 10 plus the square root of 5, remember we're multiplying by the square root of 10 minus the square root of 5 on both the top and the bottom. Alright, so try it. You can pause it if you'd like. I'm going to go through it as well. Okay, so if I do that, I get negative 3 times the square root of 10 minus the square root of 5. And remember, we can't combine the square root of 10 and the square root of 5 because they don't have a like radicand. On the bottom, the middles are going to cancel out, but we're going to do the square root of 10 times the square root of 10 because they're the conjugate, remember. And that's going to be the square root of 100. And just so you know, if I were to show this, it would be the square root of 100. Outsides would be minus the square root of 50. Insides would be plus the square root of 50. And that's why they cancel out. And the last are going to be minus the square root of 25. So that's where we get square root of 100 is 10. Oh. And the square root of 25 is 5. Okay? I'm going to also do the distributing right now because that's not going to simplify if we have a 5 on the bottom. So we have negative 3 square roots of 10 plus 3 square roots of 5 because we have minus a negative all over 5. And that is a properly simplified form of it. All right, that is the last thing I wanted to go through. I would like you to take a look at this closing question, see if you can figure it out. It says, A student simplified an expression as shown below. Describe and correct the error. So we're using the what we just talked about and see if you can figure out where the error was. Okay, and that takes us back to our overarching learning targets, which was to simplify sums, differences, products, and quotients of radical expressions. That's section 10.3. And yes, it is radical, dude. See you next time.